Here we have a pre-calculus problem. Okay, let's go to the question. If a square positive b square equals to 7ab, show that logarithm of a positive b over 3 equals to 1 over 2 times log a positive log b. Okay, now let me take this stuff. That is a square positive b square equals to 7ab. Okay, now let me add 2ab to both sides of the equation. Let me do it. Okay, when I add 2ab to both sides of this equation, here I can write the stuff, that is a square positive 2ab positive b square. On the right side, when I add 7ab and 2ab, I'm getting 9ab. Okay, here I just inserted this positive 2ab between a square and b square. There is nothing wrong with that. Okay, now let me consider the algebraic identity, that is the expansion of the square of a binomial, that is a positive b the whole square. Its expansion is a trinomial, that is a square positive 2ab positive b square. Here on the left side, we have exactly this trinomial. So now what can we write for this one? For this trinomial, we can write the square of the binomial, that is a positive b the whole square. Okay, now let me write it, a positive b the whole square equals to 9ab. Okay, now to get the square, we have to take square root on both sides. Okay, let me take square root on both sides. When I take square root on both sides, the square root and square will cancel out. I'm getting a positive b on the left side. And here inside the square root, this 9 can be written as 3 times 3, and we can write this ab. Okay, here a positive b equals to, for every two same numbers multiplied inside the square root, we can take one number out. For these two 3's, one 3 can be taken out of the square root, then we get 3 times square root of ab. Okay, here a positive b equals to 3 times, and now we can write the square root as an exponent. When I write the square root as an exponent, it will be a fraction with numerator 1, and in denominator we have to write the index of the radical. Actually, it's a square root means its index is 2, that is 1 over 2. So now we can write the square root as the exponent 1 over 2. Now we can divide both sides of this equation by 3 to get rid of the 3 which is multiplied over here. Okay, let me divide both sides of this equation by 3. This 3 will cancel out. Then I'm getting a positive b over 3 equals to ab whole to the power of 1 over 2. Okay, now let me take a logarithm on both sides of this equation. Then I'm getting a logarithm of a positive b over 3 equals to logarithm of a times b whole to the power of 1 over 2. Okay, here we can write the stuff on the left side as it is. That is a logarithm of a positive b over 3 equals to. Okay, here the argument of a logarithm is a power. Whenever the argument of a logarithm is a power, we can move the exponent, the argument in front of the logarithm, and it has to be multiplied by the logarithm. Okay, so then we get 1 over 2 times log of a times b. Okay, now let me write the stuff on the left side as it is. It is log a positive b over 3 equals to 1 over 2. Here, the argument of this logarithm, two quantities are multiplied, a and b. Whenever two values are multiplied at the argument of a logarithm, what we can do is we can take logarithm for each quantity separately and add them. So that's a product rule of logarithm. That is log a. First, let me take logarithm for the first quantity a. Now let me take logarithm for the second quantity. Then we have to add them. This is a product rule of logarithm. Okay, so using this stuff, now I proved the given statement over here, because here I got the stuff exactly what we have over here.